welcome back to another tutorial. In this case, we're going to learn how to make an amazing shockwave effects with VEX. Code in the description below. Remember to follow us on YouTube, and if you want to learn more about VFX, you can hop into my Discord channel where we are always talking about VFX, effects, composition, and look depth. Okay guys, so first of all, we're going to create our center piece, which will be a sphere. We're going to make this sphere scale set to 6, and we're going to place it somewhere here on top. We are going to use 10 of frequency, but only so we can see this smoothly. Now let's make a planar patch. Planar patch will be our ground. Let's set this edge length to 1, and let's use a circle and set this to CX and make this way bigger, maybe 25. So let's increase this until we get something similar to this. This is okay. We can see both of them like so, and I really like this. Let's do a small mounting like so, and let's change the element size so we can have a really nice grid or round. This would be okay. If we make a copy to points, we can have here a small scatter. So this will be our null outground, and we will use an object merge just so we can have this a little bit cleaner. Like so. So we have these two guys, and we're going to make maybe 6 pieces, and we're going to plug this into the copy to points with a box. This box is going to be plugged into here, and we're going to have a randomized attribute set to p-scale here. It's going to be the $os for the p-scale, like so. See, we can change this policy, and we're going to have another one for the normal. There we go. See, this will be to direction or orientation, and what I want to have is a little bit more resolution, so we can have another mounting. In fact, we're going to use this mounting here just so we can see. We're going to make this box bigger so our noise doesn't break the overall system so much. Let's see. Maybe we can use a smooth set to P. Okay, so we can have the smoother edges, and we need to calculate our normals. 2 points. There we go. So now our mountain is better. Element size can be smaller, and if we copy the points, we will have these kind of shapes. Let's look for a better seed. I think this seed is okay. The p-scale mean, I want to set this to 0.2. There we go. If we merge these two, just so we can see, we will have this ground, which is okay for the time being. We need a normal. We can see this better. We'll set 2 points. There we go. So how do we do our pulse effects? Okay, so this is the hard part, and stay with me. You will understand after a couple of wrangles how this works. So we have the sphere, right? We know that if we make a pack and then we set an add node to delete geometry but keep points, we're going to have the centroid right here, see? And we know where is our ground. Our ground is this one. So let's use an object merge like so and drag this over here. Okay, so in order to rate this or to mark the center of this grid with these points, we're going to use the intersect function. The intersect will use a couple of values. For example, the vector direction, which we're going to be setting this to 0, -1 and 0, and we will use the vector position and the UV. That's what the function expects. So we're going to use this as the int prime number of the intersection, and it will be set to 1 because we're going to intersect this with 1. This is the first input. We're going to use the position of this point. We're going to set the direction. We're going to output the position and the UV. And then we're going to use our position and be equalizing it to the position. At first, you're going to see nothing happens because the length or the distance is, this direction is not expecting a normalized attribute. So if you add a couple of zeros, the point will be set here. Now, with these points, we're going to be expecting to group this. So we're going to use the near point function to use this point here and get the closest group here. So let's use the int point of the near point of 0 based on pt1. But we don't have pt1, so let's add it. This will be the int of pt1 will be equal to 0.1 of searching this value at 0. So if we see, nothing happens. But if you have an if condition, if point is equal to pt9, then we will use an integer group underscore center equals to 1, and we will see that if we go to points, here we have 1 point which is centered. We blast it out. Here we'll have this point which is the closest one. So this will be the center. Now we're going to copy this and we're going to be using this point that we got, center one, to make a mask wrangle. This is going to be pretty easy because we're going to be wanting to make a mask based on the distance from point to every other point. Distance, this will be P, be at P with pt1. So we have mask. If we watch closely, we have mask. See? So this will be our mask value. And now we're going to be wanting to make our hardest part of the tutorial. But first, let's take a look at the center mask. See, this is our mask. If we watch closely here, we can edit this. Let's see the ramp going from 0 to 1, black to white. This is actually using auto, but if we set this to 0 to 1, this is 1 meter, and we're going to be setting this to 22. See, and this is our overall mask. Now I want to see this. I will set so far cd equals to mask. There we go. We're going to see this really high value, which we don't want to have. This will be our pulse. So we're going to deactivate this for the time being. For our pulse, we're going to have a couple of values. In total, 7. All of them are going to be float. So let's make the first one. So we want to have the max distance of our wave. This is max distance W for wave, which will become a CHF of maxDistWave. There we go. Then we're going to want to have the frequency of the wave, the freq of the wave. There we go. Which will be equal, I forget the equal here, it will be equal to CHF. Freq, there we go, freq of the wave. There we go. Let's turn this on. And then we're going to have our web load wave equals to a fit. That goes with a fit, which is using our mask, our 0 to 1, from 0, hence the middle point, to our max distance W. And it will go from 0 to how many frequencies we want to have. freqW. So if we activate this, we could see here our wave. So far, nothing until we change these values. So frequency, let's say 0.6, max wave, let's set this to 30. So we are not watching anything but a fit function. It's very simple so far. We are clamping this mask to a wave. So you watch this CD, we'll see that we are basically doing a clamp. This is going to 20, so let's use a 25. See? If we set this to 22, we'll have this type of values here. So two of the values we want is an offset, because this wave is going to be offsetted on the time. It will be equal to a SCI-FI offset and a maxValue float maxValue, which will be set to the same SCI-FI value. We are not going to use them so far, but we are going to set the value to $t multiplied by, I don't know, 0.4. So this value will increase over time, see? And the value, I want the max value to be 1. We could use other values, in this case 1 is going to be perfectly fine. And we're going to use two other floats. One is going to be our max, maxDistFade, which will be a SCI-FI maxDistFade. This will be our fadeOff. If the wave is here, it's going to be less faded than if the wave was here, which is our objective, right? Our target. And then we're going to have this fadeOff set to another function, say here. It's going to be similar to this, but with a different value, usually less than our max distance W. maxDistFade, and in fact let's change this to dist, so it's easier to read. There we go. Our distant fade, maybe it could be set to 20, just a tiny bit less than our maxDistW. Okay, so let's build our wave. Our wave will be based, of course, on our wave, but it's going to have an animation value here, which will be our offset. So let's subtract our offset, so it moves accordingly with time. This will be set to 0 to 1 and 0 to 1, just so we can see what's going on. So far, nothing is going on, at least only in the first few frames. This is because, first of all, we want to use our max value here. We want to invert this, so let's use our max value here and let's subtract this. Right? So we have the opposite. And we said that we want to have a fadeOff here, right? This is going to be like a fadeOff or a multiplication value. So let's multiply this by our fadeOff. Let's see what happens. See? And you see we are having some kind of strange value because we should have this set to 1. The closest will be this circle in the middle, and this will be set to 0. See? Now we have fadeOff. So each wave will collide into this backbone. And one thing that we need is to make this value absolute, otherwise it's never ever going to loop. So let's add an abs value. Let's see what happens. So far only one iteration. And the final trick to see this loop over time is to add a chramp, which will loop over the value of 1. So if we have this set to, for example, shape, and insert this here, we will see that this is not doing anything unless we add a small pocket here. Now we should see this kind of working, see? And we can move this so in order to shrink our hue. And let's set this to 35, and we will see our pulses going and going. We can obviously modify the shape, which is very nice, and we select all of them and add a Kaplan. This will be very smooth. Okay, so something we want to do now is copy this and create a new wrangle. In this case, this is going to be our velocity, and we're going to use angle here. Why? Because we want to be more organized with this node setup. We're going to use out center as the center point, and we're going to use an object merge right here. We're going to go to the second input, and we're going to copy this, and then we're going to use the b to be equal to our position minus pt1, but this has to be normalized because we only want the direction. So if we watch closely, we should have a velocity coming from the inner part outwards, and then we're going to make another wrangle, which this is going to be called wave mult. The idea is to multiply our velocity by our wave attributes. Now we only have velocities where we need to have. So let's use a node which we're going to call out wave. So this is our wave as far as we are concerned, and it will go forever and ever and ever. So what we want to do is, in this case, do a scatter based on our city, or in, to be more correct, on our wave. So we have this, but we have a mistake here where we can see this being black and still being affected, you see? So we're going to make another wrangle. This wrangle will be called remove, and our function will be very easy. If at wave is less than 0.01, then remove points 0 at pt9. There we go. So let's do a 30, and we only now have points where we need them to be. See? Pretty cool. And we can also make a noise that will go to our wave volume. It will be multiplicative and one direction, and we want to see this from now on here, right? So if we click this button and go to wave, we will see our values. So we should start to see something if we change these values. Yes, this is pretty much okay. I'm going to use way more points, like at least 400 times more, or 200, if that's okay. 100 acceleration set to 0. So this is okay. Our wave, we want to see these, our values, and go from 0.2 to 2. Maybe you want to remove this noise to go a little bit further. There we go. See, in this case I think this is too much, so maybe 1 will be okay to start with. Okay, so now that we have this, we can see this, and remember our collisions. We're going to use them right now. We have our ground and we have our rocks. So let's create a node. This will be our out rocks. Out rocks. There we go. With that uppercase S. So let's do an object merge and let's plug this in here. So what we want to do is, in this case, is to use a wrangle. This wrangle is to use a group. This group will be set in such a way that we're going to group each point that goes through a rock. For example, this part right here. See? So we are going to use points and only bounding box on objects. This will be called blast, and this will be called $os, which means blast. And we're going to use a blast node here, using this blast and set points. You can see this is the inverse, so we won't have something here. But I want to go one step further and do like a shadow or a forecasting of this. So how should we go through that? What we want to do is to grab our center point, and let's use a wrangle. We want to paste this as always, just to grab this point. I'm going to remove this grid and let's see where this point is. It's around here. So what we want to do is to make every face that is pointing inwards to stay static and everything else to extrude it. So let's make a direction to the point of the direct. This will be to the normalized subtraction of P at P minus PT1. Now we have a direction. And what do we do with our direction? We need to make a float dot. This will be equal to the dot product of what? Of our normal. Hence, where these points are pointing. You see, we have points going there, points going the other way, and we have the direction of each point. If each point is going to be the same, it's going to be -1, and if each point is going on the opposite direction, it's going to be 1. So we know that. So be at n and dir. So let's see what happens. We don't need double brackets. We have this, right? So let's watch this with our cd equals dots. We have -1 and we have 1, but we want this to go from 0 to 1. So let's do a fade function of this that goes from -1 to 1, and we want this to go from 0 to 1. There we go. See, now you have a value of 0 to 1, 0 to 1, and this will be called dot. And the thing we want to do is to make or multiply our P position, right? Or we're going to add, in fact, add P position to our direction, multiply by our dot, and multiply by the CHF of a volt. So if we move this further, we have this kind of result, right? This is very cool. And just to make it a little bit safer, we will use an if function that will be, okay, if. And we can use with a convert or polygon, a division polygon. We can make another group. This will be set to 1, and the group is going to be same as this one. But in this case of us, we're going to use blast because we cannot have two nodes named the same. And we're going to add this point right here. See how it adds together. So this is very cool. I really like this, and it will add a really nice resolution to our overall effect. So instead of replacing, we will union this and then blast them out. So this is how it should work. Okay, pretty cool, right? And one last final thing is to make our density the same as our wave, and then we should rasterize. When you rasterize attributes as follow. I have an already set up, but I will make it from scratch. This will be we will copy this parameter, paste it here. We will multiply this by this at the value. Oops, iterative reference, and we will divide this by 4. There we go. This should work just fine if we use density and velocity. So we have our velocities and our densities. So our velocities, if we go farther in, this will be very high. If we go further out, it will be lower. And we can obviously add a noise here at the top, before our pulse and after our mask, in order to move our wave, right? So let's have a look at this. This will go to our mask, my bad, and now what? Take a look at this. We have a mask out noise going inward and outwards. I want this to be a little bit closer and small, tuning this just a tiny bit. There we go. This is very cool. And let's use a time blend just to be sure if we use switch steps. And well, this has to go last. There we go. Like so. Okay, so we have this, and perhaps I want to, but in this case I want this to be way smaller, so I'm going to use 0.3 and velocity shattered. If we can see, we have like 33. We have our velocities working. This is just to check. We don't really need that resolution right now. So this will be our out source. Null. Out source. All this is our source. There we go. With Shift O. And now we have to prepare just a tiny bit of collisions. This is our environment, and we will use a BDB from polygon, and we will use an object merge and set this here, plug it in, and this is okay with 1, maybe 0.5. This is correlation, and this is null out call rocks. Let's do the same with the other one. This is the ground, but in this case we need to poly extrude our ground downwards on the local axis, not but the global axis, and we move it downwards like so. See? We obviously have an out of back and a reverse node. Don't forget to fill the interior. And this is out call button. Okay, now we have our collisions, and this is our environment. So if we merge all of this, object merge, this is our environment right here, and this will be our sphere. We have these two things, which looks nice overall. So now what we get to do to make our simulation, the fun part. Let's make a DOP network, and let's hop in. So our simulation will consist on a sparse solver, a small one, as objects right here, and we will volume source this here in the third input. We will have our density, but first let's grab the out source here. Out source, this will be our smoke. We don't need temperature. We'll make this 30, perhaps. We will check, and we will enlarge this content source. So let's see how it looks if we add this to 1. And before that, let's go to advanced, advection, BFEC, clamp, and then resizing to 0.1. Let's see what happens. See, we have our simulation. I think this is quite a bit too much. If we go to 0.5, we will see this better. There we go. This looks cool so far, but we need more. This is the source. Let's add the collisions. Call box. Let's go to out. Call rocks. Go to collision. We don't have velocity, so we can delete this. Let's go here and let's add a merge. And let's add the bottom, right so, and let's add this bottom here. Let's see what happens, and don't forget to delete this. There we go. This is way better. We can see this is already working, and we want to have a gas dissipate. To dissipate the smoke, set to fraction of 0.8. And a disturbance, gas disturb, set to block based 15 and 5. This should be it, and if we go to subset, let's add another one so we can have more points iterating or like a better sourcing, and we can go to 0.1 just so we can have a closer look. And let's use a DOP import fields. And let's drag this here and use the object, like so, see? And this will be smoke. We will remove our breast temperature and CD because we don't need this. Let's see how it looks. So I think this is very interesting. Maybe we would like to see this better. And visual, volume visualization. It will be set to density. And let's see what happens. I think this is cool. This is very cool. Yes, indeed. I want to have another type of rock generation, so I change the setup. Okay, this should be cool. And let's see again what happens. Yeah, this is very nice. This is very nice indeed. Look at this. Okay, so let's merge all of this together. This will be the null set to out smoke, and I'm going to add some things so we can check this out. Remember, you can do this in every version of Houdini. We are going to set this to direct range. Just follow these steps. It will be saved to where you are saving the file with the name of the node and as VHL sequence. We want to make this a BDB, and this will be smoke pulse, and we want a BDB convert so we can have our BDBs, and we will have a primitive so we can reduce the size of this volume by quite a lot using these functions. So everything should be set, and I'm going to optimize this out and make a flip. But first I'm going to add some light so it looks quite nicer. And as you can see, this effect is very cool, and you can make really creative and huge sci-fi concepts with this. Hello guys again, I hope that you enjoyed the video. If you want to learn more about this, please hop into my Discord channel and follow us on YouTube. Until the next time.